So these are the notes for standard 3.2 quantitative force models, and you can read the standard in which you'll have to select and use one of these models in order to calculate a force due to gravity, springs, or friction. So in our equation sheet, in the forces section, there are only 4 equations, and we're actually going to talk about 3 of them today. The first one is how we calculate the gravitational force, and another name for the gravitational force is weight. So you could ask, what is the weight of this item? And really you'd be looking to do this calculation shown at the bottom. In this equation, Fg stands for gravitational force, which is measured in newtons, m stands for mass, which is measured in kilograms, and g stands for the acceleration due to gravity, which is measured in, well, it's a constant of 9.8 meters per second squared. Our second equation is to calculate spring force. Spring force is shown with a capital F and a subscript S. It's measured in newtons, like all forces are. And you can calculate it by multiplying the spring constant by the displacement. And the spring constant is K, and it's like the stretchiness of a spring. And so if you have a really, really large spring constant, that means the spring is very stiff. And if you have a low spring constant, that means that the spring is very stretchy. The displacement is a change in X because you get a spring force when you stretch a spring or when you compress it away from its relaxed length. And then friction force is our final equation. Friction force can be calculated with the coefficient of friction, which we use the variable mu in order to represent that coefficient of friction. And you'll notice that the coefficient of friction doesn't have any units on it because what we multiply it by is the normal force provided by the surface that the object is rubbing against. And so because this force is measured in newtons, we can't have a unit on this coefficient in order to end up with a force measured in newtons as well. So this is one of the only values we'll see this year that doesn't have a unit at all. And those coefficients of friction are determined by what types of surfaces are interacting. So things like rubber on asphalt, that has a high coefficient of friction, whereas something like maybe oil on glass would have a much lower coefficient of friction. Thank you.